All right, we're going to go ahead and do a review for the Chapter 3 unit test. So we're reviewing for our Chapter 3 unit test. Okay, so first thing we're going to do is we are going to talk about like terms. So like terms are any terms that have the same variable or to the same exponent. So I'm going to go ahead and write an expression down. Okay, so for this expression, how many terms are there for this expression? How many terms? Well, the terms are separated by either addition or subtraction. So for this one, you have 1, 2, 3, 4 terms. There are 4 terms in this one. We can list them as x squared, 3, 2x, and 7. So those are the 4 terms in this expression. Which ones are alike? Which ones are considered like terms? Well, looking at like terms, we're thinking of, are they on the same team? So are there any other x squareds besides this one? No, there's not. What about this constant right here? So we've got 3 and we've got a 7. Those are both constants. So those are alike. Those are like terms. And this has an x, and there are no more x's. So I know you're thinking a common mistake is, well, hey, Mrs. Griffin, this has an x squared and this has an x as well. But you'll notice that this is x to the second power and this is just an x. So even though they both have x's, they're not a variable to the same degree or the same power. They're different. They're not the same. So the only ones in this expression that are alike are 3 and 7. So let's go ahead and take a look at the next problem. Okay, so in this expression down here, how many terms are there? Well, there's 5. There's 1, 2, 3, 4, 5. There's 5 terms on this one. And we would list them as 3x and then -2 because the sign to the left indicates if it's positive or negative. So -2, positive 5x, negative x squared, and a positive 1. So those are the 5 terms. Are any of them like terms? Are any of them like each other? So the like terms on this one, well, you have a 3x and a 5x. Those are alike. And you have a -2, which is an integer, and you have a 1. The only one that does not have anything like itself is this -x to the second power, because it's to the second power and there's nothing else to the second power here. So you have 2 sets of like terms in this next expression. Okay. So then we're going to move on to combining like terms. When you get a term and you want to combine it, how do we do that? So basically you have to remember your integer rules for addition and subtraction. So we have to go ahead, and so if our next expression is we're going to go ahead and combine like terms. So first of all, we know there's 4 terms here, and we're going to say, look, there's a 3x here, and there's a -x here. So I'm going to combine those. So I'm going to say, what is 3 x's? Take away another x. Well, that leaves me with 2 x's. and then here is a positive 5, and then here is a positive 2. So those are both constants or just regular numbers or integers. And so we can add 5 plus 2, and we get a positive 7. So we have simplified this expression to this. These are worth the same amount. This one is just in its simplest form. So simplest form. And you know that something is in its simplest form when there are no like terms, there are no parentheses, and there's no need for distributive property. So no need to use distributive property. All right, so that's how you would do something like that when you're combining like terms. The next type of question that we're going to work on is working on a problem that would be finding the sum of two expressions. So to find the sum of two expressions, you're going to have a problem like this on your test. I'm going to go ahead and just get a new piece of paper here. So finding the sum of two expressions is really similar to finding like terms. So finding the sum, and sum means addition. So finding the sum of an expression, what you're going to do is you're going to add together two expressions. So if you have something like this that says like 2x plus 8 and then plus 2x minus 9. So something like that. So what you can do is we taught you two different methods, the vertical and the horizontal. I prefer the vertical because you can stack the numbers on top of each other. So you have 2x plus 8, and then right below it, we're going to add 2x minus 9. We're going to add all of these together. So if I go ahead and start on my right-hand side, I've got a positive 8 and a negative 9. So this is where your integer rules come in. So you're adding these together. You have 8 positives and 9 negatives. You have more negatives than positives. And because they're opposite signs, you would subtract their absolute values. So in this case, you could write this as, to draw a picture, 1, 2, 3, 4, 5, 6, 7, 8 positives, and 1, 2, 3, 4, 5, 6, 7, 8, 9 negatives. And you'll notice that you have this one negative left over. Everything else makes a zero pair that you can just go through and cross out because it's all zeros. So that would be a negative 1, which is a minus 1. And then you've got 2 x's plus 2 more x's gives you 4 x's in total. Okay, so when you do that, you get 4x minus 1. What this looks like as tiles is 2 large positive tiles, and then this is 1, 2, 3, 4, 5, 6, 7, 8 little tiles that are positive. And then over here is also 2 positive x's, 2 positive tiles for the x, and then 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 negatives. And it's the same thing. You now have 4 positive tiles, 4 x's, and then when these get together, they're opposites, so they're going to turn into a bunch of zero pairs. You're going to be left with a negative 1. Okay, so that's finding the sum. I'm going to give you another one right now to try. Let's try this one. Okay, So go ahead and try that one. So what we're going to do is we're going to stack them in the vertical method. We're finding the sum, which means we are adding. And I have -3, 3 negatives, and 5 negatives. And together, these are the same sign, so that just means I'm getting even more negative, moving further to the left on a number line. So I owe 3 and I owe 5 more, which means I owe a total of 8. So it's a -8. And then I have 4 x's, and then I have another x, which is that has that invisible 1 in front of it. Whenever you see a variable by itself, a letter by itself, it has that invisible 1. We just don't bother to write it because 1 times anything is itself. So that's that invisible 1. And then we have 5 x's. And so now our expression is simplified because we don't have like terms. These terms are not alike. And we do not have any parentheses. We can't use distributive property. We are done. Okay. So then our answer here is 5x minus 8. And we're done with that. So now that we have found the sum, we're going to do the opposite and find the difference. So finding the difference is subtraction. Okay. And there's an interesting subtraction rule that goes with that makes it a little bit more complicated, but you will get this. So when you find the difference between two expressions, so say I have 5x minus 8, take away 3x plus 4. Okay, so remember when we're doing our integer rules for subtracting, we always want to change things to addition. And that same rule applies to finding the difference. So you want to change into addition. And how do you do that? You have to do that keep, change that we do when we're subtracting integers. So same thing, we're going to rewrite the expression. So we're going to rewrite, we're going to change it. The value stays the same, it's just an easier way to write it. So the first stays the same, so we're going to keep this the same. We're going to change this to a positive, and when we change this to a positive, we change everything in this parentheses to a negative. So we have to flip or change all signs in the last set of parentheses. Okay, so that means this was a positive 3x, it's now a negative 3x. This was a positive 4, this is now a negative 4, minus 4. So we basically kept the first one the same, changed this subtraction to an addition, and then changed the sign of everything on the inside. So when we rewrite it, we're going to have it as 5x minus 8 plus a minus 3x minus 4. So this is our rewrite right here. So now it's the exact same as the previous examples. We can stack these vertically, 5x take away 8 minus 3x minus 4, and we're going to add them together because it says to add. And we have a -8 and a -4, which give us a -12, and we have 5 x's plus a -3x, which would give us 2 x's, because 5 plus a -3 is 2. And we're done. That's it. We have simplified that expression by finding the difference. Okay, so we're going to do one more of those. Okay, so we have our expression. Here we go. And we're going to rewrite it. So we keep the first one the same. We change that to a plus. Everything gets flipped on the inside, so that turns into a negative 2x. This turns into a plus 5. And now we can do the vertical method and solve. So I'm left with x plus 6 and negative 2x plus 5. A positive 6 plus a positive 5 is a positive 11. They're the same sign, so we just keep going further to the right on that number line, and we get a positive. And then we have an x, which again, it's by itself, so it has that invisible 1 in front of it. And we have 1 x, but I owe 2 x's. So we're going to subtract those numbers. I have more negatives and positives, and it's going to be a negative x or a negative 1x. We can put that invisible 1 there. If you put the invisible 1 there, you are not incorrect. It's just the computer is not very bright, and it might think you're wrong, but it's technically right. We just don't usually write the 1. If you do, it's not incorrect, though. Okay, so we would rewrite this as negative x plus 11. Okay, so for the next example is using the distributive property. So when you use the distributive property, you need to make sure that you use the distributive property and you make sure that you are multiplying the outside term by both of the terms on the inside. Okay, so for example, if I give you a problem like this, which is say 5 and then x plus 4, okay? So when you do distributive property, you do 5 times x, and then you do 5 times a positive 4. So 5 times x would be 5x, and then 5 times 4 would be plus, and then 20. And that's it. You just have to make sure to multiply by both terms. If you have a problem that looks like this, say a negative 2x, or negative 2, and then say inside it's x minus 5, you would then say, what's negative 2 times x? Well, it's just a negative 2x, and a negative 2 times a negative 5 is a positive 10, remembering from our integer rules. And so that's how you would solve those problems. So when it has a negative outside, that negative is also distributed. So it's negative 2 times x and negative 2 times a negative 5, or minus 5. All right. So we're going to move on to solving one-step equations. So solving one-step equations, you're just using the inverse operation to solve. So if I have a problem, so these are what we call the one step. So if I have a problem like x plus 4 is equal to 13, and I want to figure out what my x is, I need to get my variable, my x, to one side of the equation all by itself. So to do that, I'm going to use inverse operations, and instead of adding 4, I'm going to take away 4 from both sides, because I want this to be a 0. So then I'm going to get x is equal to 13 take away 4. I can combine these. These are like terms. I can combine them. And so I'm going to get x is equal to 9. To check my work, I go back to my original equation, my x plus 4 equals 13, and I plug my 9 in for my x. So I say, hey, is 9 plus 4 going to be 13? And it is, so I can check that I did that correctly. To solve a one-step equation with subtraction, it would be like if I had, let's say, x minus 10 is equal to 5. So some number minus 10 is equal to 5. I want to undo my subtraction by using the inverse operation, which is addition. So I'm going to add 10 to both sides. And then I can rewrite this as x, and this turns into that 0 pair, right? X is equal to 5 plus 10, which means x is equal to 15. And then I check it. Is 15 take away 10 going to give me 5? It will. And I know I'm correct. To do one-step equations with multiplication and division, if I have 2x is equal to 22, I have 2 times x is equal to 22. To undo multiplication, I use division, and I divide both sides by 2. I divide it by my coefficient of x, so whatever number is times the x, because I want that to turn into 1x, because 2 divided by 2 is equal to 1. So I'm getting my 1 by itself. And then 22 divided by 2 is 11. So I end up with x is equal to 11. And then I check that by saying, hey, is 2 times 11 going to give me 22? And that is correct. And then next, I have x divided by 4 is equal to 3. And the opposite of dividing by 4 is multiplying by 4. And so when I do that, these cancel out to become a 1. 4 divided by 4 is 1, right? Anything divided by itself is 1. And I'm left with x is equal to 3 times 4, which is x is equal to 12. And if I go back and check, hey, is 12 divided by 4 going to give me 3? Yes, it will. And then that is a check. So that's how you do the one-step equations. Moving on to the two-step equations. So the two-step are very similar to the one-step. It's just you have to do something first to get to the one-step. So two-step equations. So on a two-step equation, you want to undo or get rid of addition and subtraction first. You need to undo those first. So if I have a problem such as 4x plus 5 is equal to 25. Okay, so I want to undo addition subtraction first. So there's the addition. I want to get my x by itself. I want to isolate my x and solve for x. I want to find a solution for x. So I can say, I need to undo addition and subtraction first. So there's addition. I want to undo that by using the opposite or inverse operation. So I'm going to take away 5 from both sides. This turns into a 0 pair, right? And I can just get rid of that. And then I can rewrite this as 4x is equal to, and then 25 minus 5 is 20. So now right here, I'm now at a one-step situation. So I got rid of the addition subtraction first. I'm now at a one-step situation. And then I'm going to divide both sides by 4 to get 1x. And 20 divided by 4 is 5. So I'm left with x is equal to 5. And then I can check that by saying, hey, is 4 times 5, right? 4x, x is 5, plus another 5, is that going to give me 25? And if that makes sense, and it does, then I am correct. Okay? And then let's try another one. What about 6x minus 3 is equal to 15. Okay, so 6x minus 3 is equal to 15. So same thing, I want to undo addition and subtraction first. Whatever's next to my x needs to go away. I want my x by itself over here. So I'm going to get rid of this negative 3 or this minus 3 by adding 3 to both sides of the equation. Whatever I do to one side, I need to do to the other, or it won't be balanced. It'll be like a seesaw that's out of balance. So I'm going to circle that. That's a 0 pair. And I'm going to rewrite this as 6x. So that's a 0, so I can get rid of that, is equal to, and then 15 plus 3 is 18. So now I'm in that one-step situation. So 6x is equal to 18. I'm going to divide both sides by 6 because I want to turn that into a 1x. And I'm left with x is equal to 18 divided by 6, which is 3. And then I'm going to go back to my equation and say, hey, is 6 times 3 minus 3, is that going to give me a 15? And this would be 18 minus 3, is that 15? 15 is equal to 15. So yes, I did that correctly. Those are the main problems that you're going to have on your test on Thursday or Friday. So go ahead and study this. If you study this and you practice this, you will do very, very well on your exam for Chapter 3 test. If you do this lesson and you still are having questions or don't understand, please come and see me or see your teacher at intervention. Thank you.